All right, so today we're going to start with permutations and combinations. We got to start thinking, what is permutation to begin with? Now, a couple things I want to mention. Let's say that I had four letters, just to say A, B, C, D. All right, this could be four letters, this could be four books, could be four people, could be four of anything. And then I ask you guys, line them up in any order you want. So I could have like A, B, C, D. Right, that's an order. Another way I can line them up will be like A, B, D, C. How else I can line them up? I can do A, C, B, D. I don't have to start with the A. I could do B, C, A, D, and like a bunch of ways, right? I could do the long way. I could actually come up with all the possible ways. With four letters, putting in any order I want is not too difficult. I could even say, well, mathematically speaking, I have four letters. How many choices do I have for the first letter? I have four. Right? I could choose A, B, C, or D. Now that I chose a letter, right? So let's say I chose A, just to say I chose a letter, I ask myself, how many do I have left for the second letter? Well, I have three times. Now that I remove the second letter as well, how many choices do I have for the third letter? Well, I should only have two. Now that I removed three letters, how many choices do I have left for the last letter? One. If I multiply these two things together, all these, 4 times 3 times 2, that happens to give me, times 1. 4 times 3 times 2 times 1, that happens to give me 24. Now, what does this 24 mean? Is that if I came out and organized my four letters in any way I want, I will come up with 24 possible solutions. Now, 24 is not a big number. I can come up with all 24, but what if I gave you guys a whole alphabet? And I ask you guys, how many possible choices can you write? Now, that's a big number. I'm not going to do it the long way. I'm going to do this. Now, interesting part, this is where we come out with permutation. The way we're going to write this in permutation, we're going to use the P for permutation, and I'm just going to say from four letters, I'm going to choose 4. And then the way we're going to write this, we're going to write this as 4 factorial over 0 factorial. I'll talk about what factorial means. 4 factorial over 0 factorial. The 4 on the top comes from this number. Now the 0 at the bottom, I subtracted my first number minus the second number. That's how I got the 0 factorial. Now what does factorial mean? Is I'm going to be multiplying my 4, for example, I'm going to be multiplying with, starting at forward, all the digits until I go down to 1. So I'm going to go 4 times 3 times 2 times 1. 0 factorial will always be 1. So notice that's exactly what I wrote at the beginning. 4 times 3 times 2 times 1. I'm going to be multiplying, and starting at forward, all the way down. 0 factorial is 1. Now, your question might be, okay, what if I have 5 letters? What if I have 5 letters? I'm just going to say A, B, C, D, and E. And I want to just choose 2 letters. How many orders can I come out with? Once again, I can do this the long way. A, B, B, A, C, C, A, on and on and on and on. Or just doing the idea of permutation, I'm going to say from 5 letters that I have to choose from, I'm going to do 2 letters, right? I'm going to be ordering them in pairs, groups of 2. So how am I going to do this in mathematical work? It's going to be 5 factorial over 3 factorial. Once again, the 5 from my first number, and my 3 at the end because I went 5 minus 2. All right, so remember factorial, I said it was the number that we start with is that one in given. So 5 factorial, I'm going to start with 5. I'm going to be multiplying my digits all the way down to 1. So I'm going to go 5 times 4 times 3 times 2 times 1 over 3 factorial is the same thing as 3 times 2 times 1. Now you might even come and say, well, I have the ones from the top and the bottom cancel out. The 2's cancel out. The 3's cancel out. Good. So I just have 5 times 4. 5 times 4, that will give me 20. So, matter of fact, let's take a look at a couple of our examples. How does our homework might look like? 7 permutation 4. Okay, so how does that look like? So I'm just going to do 7 factorial over 3 factorial. Once again, what permutation means is if I had 7 things, right? 7 letters, 7 pencils, 7 anything. I want to make groups of 4. I want to list them up in, if I have 7 letters, I want you to list 4 letters, any order you want. So I know 7 factorial, mathematically speaking, is 7 times 6 times 5 times 4 times 3 times 2 times 1. Right? From 7, I'm multiplying all my digits all the way to 1. Now, what's 3 factorial? It's 3 times 2 times 1. The 3's cancel out. The 2's cancel out. The 1's cancel out. I have nothing at the bottom. So now for the bottom, for the top, I have 7 times 6 times 5 times 4. Let me figure what that is. I have 7 times 6 times 5 times 4. So my answer in this case is 840. If I had 7 letters, and I'm gonna line them up in 4. I'm just gonna line up 4 letters out of 7. How many possible ways can I come up with? 840. Now, let's take a look at our question number 2. I'm gonna do 7 factorial over 2 factorial. Remember, I have to, the 7 from the top is my first number. My 2 at the bottom, my 2 factorial, because I subtracted 7 minus 5. All right, so what does this mean? On the top, I have 7 times 6 times 5 times 4 times 3 times 2 times 1. At the bottom, 2 factorial, that's 2 times 1. Let me cancel the 2's. Let me cancel the 1's. So on the top, I have 7 times 6 times 5 times 4 times 3. That is 2,520. So my answer would be 2,520. Now, when you type this, it's optional. If you want to put the little comma, because I know back in elementary, you guys were told you must separate the numbers by groups of 3. So 2,520. Like you can type in the comma, or if you just type in the digits 2520, the homework will be marked correct. Either way, except the little comma is optional. So that's how we do permutation. Now, what does combination mean? Combination means, let me explain something about combination. Let's start with, once again, like I started, we know a permutation. Let's say I have 4 letters, A, B, C, D. Remember with permutation, I came in and said, let's say for permutation 2. Remember I said line them up in groups of 2. So AB and BA, I consider them separate because that was a different order. That's in permutation. Now in combination means, hey, as long as you choose the same letters, it doesn't matter which order. So sometimes people call, instead of combination, people call it choose. So what this means is, let's say I had 4 letters. I want you to choose 2. It doesn't matter which one comes first. So A, B, and BA, I'm going to consider the same thing. So the way we're going to do this, let me explain this with an example. "23 choose 19." Well, 23 combination 19. That means if you had 23 items, or let's talk about this, when you guys play sports, let's say there's 23 people, and then you need to choose 19 people. How many possible ways can you choose? 19 people out of 23. Now this way, we're going to start with the same thing as we started permutation. I'm going to do this as 23 factorial on top over 4 factorial. Right, the 4 factorial because I subtracted 23 minus 19. However, because remember how it said in permutation, the order did matter. In combination, the order does not matter. So at the bottom of combination, or choose, how people call it, I'm going to do 19 factorial as well. So the 23 factorial on the top, we know where it came from. Now, from the 2 factorials, notice I have at the bottom of my fraction, I have 2 factorials. The first one, the 4 factorial, because I went 23 minus 19. For the second one, I just chose the 19th, this second number. All right, so let's see. Let's see what I have. From the top, let's see, I have 23 times 22 times 21 times 20. Let's just say times 19 factorial. Remember, 19 factorial stands for 19 times 18 times 17 times all the way down. So notice I went 23 times 22. I'm going down. 23 times 22 times 21 times 20 times 19 factorial. Why did I stop at 19 factorial? The reason why is because at the bottom I have a 19 factorial. So why am I going to write 19 times 18 times 17 all the way to 1 in top and bottom? Why am I going to do it twice? Now, at the bottom, I also have a 4 factorial. That is 4 times 3 times 2 times 1. Let's see what I can cancel out. The 19 factorials. Because remember, each of them represents 19 times 18 times 17 all the way to 1. Now, here, let's see, what do I have? 4 times 3 times 2. That's 12, but I don't have a 12 on the top. Now, I can multiply on the top. Let's see what I have. On the top, I have 23 times 22 times 21 times 20. That's what I have on the top. 212,520. Over. Now, what do I have on the bottom? I have 4 times 3 times 2 times 1. And that gives me 24. Now, let's see what I get in this fraction. 212,520 divided by 24 equals 8,855. So my answer is 8,855. I'm going to use the comma for the thousands. But once again, the comma, when you type in your answer, it's optional. If you just type in the digits, 8855. That will be marked correctly. Let's do another example. So let's say here, I'm going to say 14 factorial. To begin with, I have 14 factorial. At the bottom, let me subtract these numbers. 14 minus 7, that gives me 7 factorial. Using my second number, I have 7 factorial. All right, so let's see. What does 14 factorial really mean? It means 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 factorial. Once again, that 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. Over, I notice here at the end I have a 7 factorial, and that's the reason why I stopped my fraction at 7 factorial. Because I knew those two were going to be able to cancel out. Good. Now I still have this other 7 factorial. What does that mean? It means 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, so what do I have on the top? After I simplify, I cancel out the 7 factorials. I have 14 times 13 times 12 times 11 times 10 times 9 times 8. So on the top, I have 17,297. 17 million. Let's see, I have 17,297,280 over. Okay, what do I have at the bottom? Let's see, I have 7 times 6 times 5 times 4 times 3 times 2, 5,040. So I have 5,040. All right, so going back on the top, I have 17,297,280 divided by 5,040. And it gives me my answer is 3,432. 3,432. Now, when can combination be used? Let's say I had a pizza parlor and I had 10 toppings. And then I want to come over and say, well, I have many choices. Many choices. If you want to get a 2-topping pizza, I have 10 choices because I have 10 toppings. I could ask people, how many 2-topping pizzas can you get? 10, choose 2. That's when combination is used. Obviously, I will come over and I will use that. If I had a pizza parlor, I will promote, I have this many 2-topping pizzas. Now, when else is it used? When you play the lottery. How many possible choices can you come out with? I think it's 51 numbers and you have to choose 5. Plus, whatever it is for the mega number. So 51, choose 5. How many possible choices can you do that? And then times, how many mega numbers are there? And that's when these things are used. So this is going to help you guys for your homework. This is how permutations and combinations are done.